Hello everyone. Let's understand the structure and interconvertible nature of chromate and dichromate ions. So in this particular video, you would be understanding how to represent chromate and dichromate ions. At the same time, how do we convert chromate ion to dichromate and vice versa? That is, under what condition these reactions can take place. Let's first understand the structure. We have chromate ions and dichromate. The basic difference between both the ions is definitely the representation, that is CrO4. Only one chromium in chromate, whereas dichromate, as the name suggests, we have Cr2O7. Okay, how do we represent the nature or the structure of chromate? Chromate has central chromium and 4 oxygens are arranged in a tetrahedral fashion. So we have 4 oxygens arranged in a tetrahedral position. Tetrahedral meaning your central atom would be over here and there would be 3 subdivisions together and one would be far apart. This particular tetrahedral division is very much characteristic with a bond angle of 109.5 degree. Okay. Whereas in dichromate, again we see tetrahedra but with 2 chromium ions. Here we have the 3 subdivisions. Again, the 3 subdivisions occupied by oxygen each. And instead of having 2 separate oxygens for the chromiums, we have 1 linked oxygen. Now, this is how a tetrahedral looks like. So if you are paying attention to the laser pointer, we have a straight line and 3 subdivisions, right? So we are looking at tetrahedra. The characteristic feature of ditetrahedra or bitetrahedra is the bond angle of 126 degrees. So this is our only tetrahedra, that is only one tetrahedral structure. Whereas this one is bi or ditetrahedra. And that is how we try to understand the structural representation. Another thing that becomes pretty much of importance over here is the charge on chromate and dichromate. Both chromate as well as dichromate carry an ionic charge of -2. So whenever you're representing this structure in examination or in some paper, you need to make sure to draw a square bracket indicating the entire structure has a charge of -2. Same goes over here and you indicate it as -2. This completes the representation part of our chromate and dichromate. What I want you to focus on next is the oxidation state of chromium. Oxidation state of chromium in chromate, whereas comparing it with oxidation state of chromium in dichromate. We all know chromium happens to be a D block element or famously known as transition element, and they show variable oxidation states. So let's see how things work. For those who are looking at oxidation state for the first time, it's simple. 1 chromium atom plus 4 oxygen atom. What's the total charge? The total charge is -2. So you put -2 over here. Another thing that's pretty obvious over here, oxygen carries a charge of -2. Okay, so chromium becomes -2 plus A. Hence, the charge over chromium or the oxidation state over chromium is +6. Let's see in dichromate how things are working. We have 2 chromium atoms. We have 7 oxygen atoms and the total charge of the ion is -2. Again, evident that oxygen carries a charge of -2 itself, and there's -2 outside. 2 chromiums giving me let's say, +12 over here. Chromium gives me an oxidation state of +6. So while both chromate ion as well as dichromate ions show an oxidation state of +6. That is all that we need to know about the ionic structure and representation, as well as oxidation state of chromium, okay, in the respective ion. The next thing I want you all to focus on is interconvertible nature. Interconvertible nature of chromate and dichromate ions. So let's say we are provided with chromate ions. Okay, nobody provides you directly with chromate ions. You might have potassium chromate, sodium chromate, something which has this representation of chromate. Okay, and we are expecting you to convert it somehow into a dichromate structure. Now, first of all, here there are certain rules that we need to follow. Whenever you want to convert chromate to dichromate, we prefer an acidic medium for the bonding. Okay, so acidic medium provides the necessary condition to convert the simpler chromate form into a complex dichromate form. And let's say if you want to convert this dichromate back to chromate, you go for a basic or an alkaline medium. Okay, you're trying to bring it down on its complexity. Here, because we are using chromate and converting it to dichromate, we are bound to use an acidic medium. The best way to represent an acidic medium is using H+. Protons are rich in acidic medium. Let's start with the first notion that we can see. We have 2 chromiums over here, 1 chromium over here. You just put the coefficient 2. Now, what all things do we have? We have 2 chromiums. Yes. Do we have 2 chromiums? Yes. Let's see on oxygen. We have over here 2 4s are 8 oxygen. And here we have 7 oxygen. Fine. So on the reactant side, we have 1 oxygen extra. And we need to make sure that this extra oxygen gets somewhere. For that, the proton in the acidic medium is going to be of a huge help. The proton picks up this particular oxygen and forms water. For water, we know one thing for sure, it is always given by a formula H2O. Correct? It's H2O. So how many protons? We have only 2 protons over here. So we need to put 2 number over here. This is how you convert your chromate ions to dichromate. Now one might be thinking, how do we go back? Let's say dichromate has been formed. Now what to do? Well, it's not as simple as just adding dichromate with water and you getting it back. Rather, it is a bit on a different aspect. Whenever you get dichromate, that is a complex featured compound, you are going to make sure to put it in some kind of basic or alkaline solution. I'll tell you why in a minute. To convert it into your chromate ions. And why does that happen? What is the necessity over here? The necessity over here is pretty simple actually. When we have our dichromates present, they are already in their maximum complex state. Correct? In that condition, you cannot add more protons and complexify the compound even further. To bring it down, there need not be a constant condition. See, acidic condition is the one which gave rise to dichromate. You can't keep putting more acid or more protons in that dichromate to convert it back. So here you need to change the medium completely. You need to change the pH of the medium completely. That is the reason why we shifted to basic. Let's see over here what things can we notice. We have 2 chromiums. Yes, we have 1 chromium. Okay, we write down 2. Okay, up here, I think things are pretty clear. We have a hydrogen, we have an oxygen. We know the drill, right? We'll make them as water. Now let's see how balancing works. Chromium is settled. Yes, chromium is very well settled. Let's see, hydrogen is settled. No, I can see two hydrogens, but only one hydrogen on the reactant side. So we'll add the coefficient 2. Okay, now let's check upon oxygen. We have 7 oxygens here. We have 2 oxygens here. 2 4s are 8. We have 8 oxygen here. And we have 1 oxygen here. How much are we getting? 7 plus 2 equals to 9 oxygen. 8 plus 1 also equals to 9 oxygen. That means that we have arrived on a basic, or we can say the general equation. Our equation is balanced. What is the key factor in interconvertible nature? That when you want to complexify your chromate ions into dichromate, you add an acidic medium. Helps with the bonding part. Whenever you want to bring your dichromates back to chromate, you switch the medium to basic or alkaline, and hence you get your chromate ions back into the picture. Okay, I hope you have understood. If you have any doubts, please let me know in the comment section. Signing off. Bye.